Hello everyone. Welcome back to the series where we are understanding the concepts of system design and where we are trying to solve problem where we have a system which serves one user and we are trying to scale it. And in parallel we are understanding all the concepts that come in our way. So till now we have understood how the client server model acts and what is a DNS. Now moving forward we will scale further. So in this uh, video, we will talk about scaling the database. So as we talked in my previous video that the server over here is one big black box. We have to unbox it. We have to scale in such a way that our one user which is being served comfortably with this system, there our system should become in such a way that it should serve multiple users without any lag, without any latency. I mean, latency would be there, but we will try to decrease the latency as much as possible. So the main concepts we will talk about in this video is database. So let's say your understanding over here is you sent a request to the client browser sent the request to the DNS resolver, found the IP address, sent the request to the backend server. Backend did some calculations and sent you the response. Now, this box over here, you see the server. If you keep in this way, if you start working on a project on your laptop, it will be something similar. The server, the whole laptop will be server. It could be single point of failure. Now you don't want single point of failures in your system. So in that case, what you do is you start segregating the. So the first component that we will segregate over here is database. Now, now segregating database, what I mean is you unbox this box, you pick the database and move it to a different server, different computer. So doing that will solve your single point of failure. Let's say your uh, laptop is corrupted, your data is still safe because you have moved the data in the different server. So let's talk about the transactions right now. When you start a simple project, it comfortably honors some request. But let's say your system becomes popular. In that case, what happens is you start experiencing more traffic. And in that case, your system, your project that was running on your local will not be sufficient. You will have to scale up. So in that case, what you do is you introduce more powerful database, which will, let's say, honor 100 transactions per second for you. And uh, you are happy with it. Now you are happy that your request, your project is comfortably honoring 100 TPS. And what you did is you segregated the database and you scaled the database. You put up more powerful machine so that your 100 TPS can be achieved. Now let's say your particular website became more uh, famous. Now your 100 TPS becomes 200 TPS. So your this database, the database that you configured, that machine that you configured for 100 TPS, will start lagging, will start crashing. It will not be sufficient for the load that is start coming because your website has become popular. Now what you do is you introduce one more database and one more database server, and you say that I'll do all the read operations to the follower database and all the write operations to the leader database. Also, along with write operations, all the critical read operations will be done from the leader database. So this concept will give you some breathing time. And what it does is now you have created one more database server, you have introduced replication on that, and Whatever your write operations are coming, you are putting on the leader database, and whatever the read operations are coming, you are putting on the follower database. Now your 200 TPS will be honored and you are comfortable for some time again. Just to repeat, you were you started with your local database, then you moved the database to the different machine, and you made the database little powerful so that it honors 100 transactions per second. Now your database become popular. Now you are experiencing more traffic, and instead of 100 TPS, the load has doubled. So you introduced a read replica, and you are comfortable now. Now moving forward, let's say your website became more powerful. Sorry, your website became more famous. Now let's say you are experiencing 100 transactions per second now. Your website has become popular, and you are experiencing 100 transactions per second. Now what you do is you increase the capacity of your machines so that your machines become more powerful, and you shed the load, saying that let's say my 50% of the traffic will go on this follower. Again, we are following the same concept. All the critical write operations are going to one of the leader, and all the read operations are going to the follower. So hope you understand where I'm going, because there will be a certain limit where you can say that, okay, I have put the most powerful machine for my database, and all I could achieve is 1000 transactions per second. But going forward, let's say you have to uh, going forward you have to experience more than 1000 transactions per second. So what I'm trying to say is you have reached the vertical limit, and you cannot add more powerful machines. So that's where the horizontal scaling come into picture. So what you do is you scale out instead of scaling up. Till now we were scaling up. We were adding machines more powerful so that our transactions can be honored. But now you have added the most powerful machine you can afford, and you are still at the 1000 transactions per second. But going forward, if your traffic increases, you cannot add more machines. So you will start losing business. That's where horizontal scaling comes into play. Horizontal scaling is you use the same machine, but you place your data in such a manner that your queries are faster, your queries are faster, your load on database is lesser. And how do we achieve horizontal scaling is there are certain concepts. First is partitioning, and second is sharding. Let's talk about these concepts. Now, now partitioning is splitting the data within the same instance. The data could be the subset of the whole data. So let's say you have 1000 rows and you have applied sharding. I'll come to it. I'll explain what sharding is. And uh, you have got out of those 1000 rows, you have got like 5 shards. Let's say each shard contains 200. And that particular shard is called the subset. And partitioning can be applied on that particular subset, and the use of it is, let's say for example, the column that you see here, the columns that you see here, ID, name, city, budget, and gender. So name, city, gender, and ID are not changing very frequently, and some of them do not change at all, like ID and gender. But Budget over here is a frequently changed entity. So what we do is we apply partition so that the right operations happen on that particular set of data, that particular partition of data only. So this is where partition helps. Now moving on to sharding. As I explained, you have, let's say, thousands of rows, and you have applied some logic, and that logic says that the names starting from A, from the letter A to, let's say, D, lies in one shard. So whenever a new write operation comes, that write operation happens on the basis of the name. And my name's first character is, let's say, A, then it will go into the shard 1. Similarly, we have multiple shards so that my data is logically separated. This is called logical sharding. Now, similarly, we can do physical sharding also. So, physical sharding is when the database is sharded across multiple machines, and you have included n number of machines, let's say 5 machines, and all those 5 machines have unique data. So that is called physical sharding. You have created 5 database servers, and all database servers have some set of data. But point to note over here is all these 5 servers containing data, that data will be part of the same data schema. So try to understand in this way. You are working on just one database. On very high level, you are just seeing one database schema. It has thousands of rows, but underlying, the developers, the team have distributed the whole data on 5 servers. They are consolidated on the basis of some logic, combination of some logic and physical sharding. And that logic can be, the logical sharding can be on on the basis of any logic that you feel that. So let me rephrase. Logical sharding is a concept where you use one of the column or multiple columns to derive to a formula saying that this particular set of data will reside in this shard. So let's say, for example, um, Tinder. So Tinder works on location, and the data that uh, it stores in such a way that the users are the user's data is stored on the basis of location. So the sharding over here is done on the basis of location. Similarly, there can be any column that you can use so that you can distribute your data evenly across all the shards. The benefit of it is the database operations will be quicker, the latency will be lower, and your system will be faster. So this is the software layer. This is the software layer which has some algorithm, and that algorithm gets the key on which you want to apply the shard. And in our example, let's say we took the name. We wrote an algorithm that's saying that it should give me the shard ID where my data should go. So it performs the algorithm, and on the basis of result, it chooses the shard in which the data should appear. And doing this helps reduce the latency, helps scale your system horizontally. So there are n number of algorithms or techniques that people use to create the shards. So the very first approach we took, the very first algorithm or very first technique that we use is range based. So this example we already discussed. Similarly, there is a hash based. So you pass some of the one of the shard key, and you have a hashing function which calculates the hash on the basis of your shard key. So this particular range based is not very popular because it could lead into hotspots. So let's say lots of people with name range starting from A to I are there. So all the data will start going into your shard 1. So this is not very popular. So what we do is we do the hash based, and hashing we do on the basis of any other or any sharding key, which is better than range based. What hash based does is it takes the shard key, it passes that shard key through a hash function, and it generates the hash. Using that hash, we find the index of the shard where our data should reside. And the hash function must correspond to some business value. Then only we will have the correct data placement. Similarly, we have other sharding methods like geo-sharding, directory sharding, etc. There are a number of techniques. So that's about horizontal scaling. Just to conclude, what we did is we started moving out our database. Then we thought of vertically scaling, but we reached to a threshold. And then we started horizontally scaling. And we understood what partitioning and sharding is. So in next section, we will again keep on unboxing our uh, server box, and we will understand more concepts. Thank you for watching.